When it comes to programming of a PLC, the PLC can be programmed in one of two ways, in one of three different languages. The three different languages that PLCs use, firstly, is ladder logic. This is the most common one, and this is the one that we're going to focus on. The second type is called an instruction list. And the third is the logic block diagram. Now, the ladder logic is the most commonly used, and it's simplest when it comes to motor control circuits. The logic block diagram focuses on logic tests and combination of logic states of the inputs, and then when you download onto a PLC, the program converts whichever language you programmed in into an instruction list. Now, the main reason why we use a computer or a program in order to program a PLC is because it allows us for more accessibility, and also it makes the programming procedure a lot simpler. Some PLCs actually do have buttons and a display unit on the PLC itself, which allows for simple tweaking or minor alterations to a program, for example setting the time or changing a normal open input into a normal closed input. But the writing of an overall program, especially for large systems like in manufacturing, is done on computer, as it allows for more accessibility. Let's look at the interface on the Logo Soft Comfort program that we use to program our PLCs. Create a new file or create a new program. Click on the top left of the screen. That brings down what type of design you're going to make. Let's make a ladder diagram. Now, looking at the options over here, there's your typical new, open, close, print, copy, paste, cut options that you get in all Windows programs. On this side, we've got a switch logo mode. We've got the download PC onto the logo option, upload from the logo to the PC or from the PLC to the PC. Here we've got zoom buttons, and then we've got a page layout which has to do with the printing. This button converts whatever ladder diagram you've got into a block diagram. And then there's content sensitivity help, which is if you click there and you click on any button, then it will identify what is happening over there. Now, the inputs, different types of inputs and outputs we can find in this left hand window. Okay, firstly we've got the constants. Those are your make and break contacts, relay coils, inverted outputs, and so on and so forth. Then we've got special functions, which include timers and time sensitive options. Then we've got counters, which will identify or add or subtract whenever an input is triggered. Going down, we've got analogs. These are analog, or these work with the analog inputs and the analog or analog option inputs. Then we've got miscellaneous, where we've got logic gates, latching, relays. Let's just bring that down. Message text that goes on the display of the PLC if you so want it. And then over here we've got some additional options. There's just your select button. There's for if you want to insert comments, cut and join connections, make connections, constants and connectors. These are shortcuts for this window, special functions, which is a shortcut for this window. And then there is your simulation, whereby you can actually simulate the operation of your network that you've drawn. Let's start off simple. We're going to make a direct online starter, starting with a make contact. Just click and drag, and then you can insert that input, and you select where it's going to find that input, on which input pin. I'm going to say pin 1. I want to name this one my overload. Okay, then we add the second one, which is input 2, and we are going to name that one the stop. Okay, naming is not required, although it does make it simpler for further and future referencing, specifically when you're working with more advanced circuits. Okay, we've got the stop, then we've got the emergency stop, and we're adding the start button, which is going to be number 5. No, that's supposed to be number 4. And this is my start. Then all of that has to go to my relay coil, which is my output. Just going to make some space over there. This is my no volt coil. Okay, then we're going to make our latching contact, and we go find that output over there, which was labeled Q1. And then to finish up, we just draw in the connections, we click and we hold from the beginning to the end, and that joins all our points. We can see if there's an incompatible connector, it identifies it. So you just find where it connects or it links, and then we've got. Now we have to remember that this is going to connect, this start button is going to connect to a momentary make button. The stop is a momentary break button. Overload is a normally closed button, which is either open or closed depending on the state, and then the same with the emergency stop. Now when we run our simulation, we go to tools, we run the simulation, and then the red shows what's active and the blue shows what is not active. Now we have to remember that switch 1 Well, input 1 is my overload, which is closed, and my emergency stop is also closed. So now we can see that there is a connection that stops at the start and at the no volt coil latching contact. Now the moment I click on the start button, it closes the circuit and it activates my no volts coil. When I release the stop button, it goes blue again, but the latching contact is keeping it active. Now when I break the overload, everything stops. Start the circuit when I press the stop button momentarily, then everything stops. Let's start it again, and the emergency stop will also deactivate the entire circuit. Once you're done, you can save. Using the file option. It's still running the simulation, that's why. Just leave it, and we can say file, save as, and we identify the name. This is the ladder diagram. We can switch to the functional block diagram by clicking on that button over there, and then it would show us what type of circuit we're looking at. We're looking at, there's our different inputs, there is our logic gates that all run into my output over there. OR gate, AND gate, another AND gate. And then once you're happy, or once you've done that, if you're going to use this type of network, then you can tidy it up just by clicking and dragging on the different lines that are created between the devices. This is the second language. Once I upload the program to a PLC, that is when it converts this into an instruction list.